So far, we've done molecular orbital diagrams for nitrogen and neon. They don't have too many electrons. But what if you get an element that has an enormous amount of electrons and you don't really want to draw out all those boxes? There's a shorthand method to drawing these diagrams. And using the shorthand method, you always consider noble gas nearest to that element that has a lesser amount of electrons. I'll illustrate. He has 35 electrons, and that's a lot of electrons to draw out on a diagram. The shorthand method is to consider the noble gas that has fewer electrons that's most near to, and if you go backwards instead of forwards on the periodic table of elements, argon is the nearest noble gas with the less amount of electrons. Argon has 18 electrons. If I were to subtract amount of electrons, 35 electrons minus 18 electrons, this equals 17 electrons. The shorthand method to represent all the electrons in, usually it's written with the noble gas, argon, in brackets, and then you fill in the diagram with the amount of electrons left over, 17. We start filling in our boxes. Our first orbital can only have 2 electrons in it, 4s2. And remember, our principal quantum number explains the distance from the nucleus. This 4s is getting further and further away. 3d is even further. For our D shape, our complex electron cloud, we have 5 boxes, and that could fill up to 10 electrons. 1, 2, 3, 4, 6, 7, 8, 12, and that filled up, that's all 10. 12 electrons, I still need 5 more to go. 12, 13, 17. And our 4p orbital filled up with 5 electrons. This is the shorthand method of representing on a molecular orbital diagram, and it's not too difficult.